We're firing a rifle bullet straight up from the surface of the moon, right? This is a raffle. R-A-H-F-L-E, raffle. It will be the greatest height it would reach. So let's draw a picture of this. Here's our moon. Here's its center. We are already not on the center. We are this far. We're 1.74 times 10 to the 6 meters from the center as we stand on the moon's surface. Firing that rifle, we fire the rifle straight up. And it's going to go up to some height like this. Right? And then it's going to come back down, right? So we are already some distance, I'll call it R1, from the center. And we're going to figure out how far it goes. I'll call that R2, like how high it goes. And of course, at its greatest height, the final velocity will be 0, because if it's not 0, it's not at the top. Yeah, there we go. And this really would work on the moon because there's no atmosphere on the moon, so you could actually do that. I mean, if you actually could fire it straight up, it would go, and the Earth and the moon weren't rotating, right? You could shoot it straight up, and then it would go straight back down, land in the barrel at the same speed largely, right? Because there's nothing out there, right? Okay, so let's set this thing up. We've got, on the surface of the moon, we're going to have potential and kinetic because you're firing it from the surface, right? So we've got minus G, the big M will be the moon. The rifle bullet will be little m, right, over R, and I'll call that R1, right, plus whatever the speed of the bullet is, so 1/2 little m, the bullet's mass, right, times its velocity squared, right, and then that's going to equal, when it reaches this height, all it has is potential energy. It won't have any kinetic because it's not moving at the top, right, so minus G, big M, little m, over R, I'll call that R2, right? And then that's it, right? So at the greatest height it reaches, it only has this potential energy here. So let's just plug in numbers here. So the opposite of 6.67, E minus 11. Don't forget those minus signs, okay? Times 7.35, E22, times 2.3 grams would be 0.0023. And then that's divided by 1.74 E6. Okay, and then plus 1/2, 0.0023 times, then we know the velocity, 1150. And then that's going to equal the opposite of 6.67 times 7.35 times 0.0023. And then that's going to be over, this is what we're solving for, is how high it gets, right? Now, understand that once we solve for R2, that won't be the answer, because the answer is this distance here. Right, so we're going to have to subtract, I think R2 minus R1 will be how far we are above the moon, right? How far we are from the center minus the radius of the moon will be how far we are above the moon. Okay. Now, if you're paying careful attention, do you see that that 0.0023 is in every factor here? So I'm just quietly not going to type it into my calculator. So to solve for R2, I'm going to go this times this divided by this entire left side. Okay. So the opposite of 6.67, E minus 11 times, don't forget the minus signs. These are important. That's an exclamation point, not a turd. Okay, times 7.35, E22, divided by left parenthesis, and now I'm just going to type this whole side in here. The opposite of 6.67, E minus 11 times 7.35, E22 divided by 1.74, E6 plus, notice I'm not typing in the 0.0023s because I'm a bad boy. All right, plus 0.5 times 1150 squared. Whoops, that'll mess it up. There we go, right parenthesis because I'm ending that thing there. And That dog didn't hunt. Let me see what I do. Oh, that thing got squared. That's fun. Let's delete that square. Delete it. All right. There we go. That's better. Okay, so I'm getting that R2 is 2273600 meters. That's how far we are from the center, right? Well, we want to know the height, which that would be the distance above the surface of the moon, right? So the height is going to be this minus the radius of the moon, right? So 2273600 minus 1.74 times 10 to the 6th. So by the way, that's 2.27 times 10 to the 6th. Right, that'll be the height, because we want to know how much farther from the center, from this center of the moon are we than the surface is, right? That's what we're doing. So minus 1.74 E6, and I get 533,600 meters, which is 534 kilometers, roughly, right? Because a kilometer is 1,000 meters, right? It's 533.6 kilometers here. Okay, so that's how you figure how far the greatest height. That's a little bit tricky, right? The nice thing about these is you can cancel out one of the factors, but that's a tricky thing, right? How far above the surface are we, right? All right.